Hello, and thank you for joining us today. I'm Janine Thorpe from Salesforce.com's marketing team, and it's my pleasure to welcome you all to 7 Steps to Business Success on the Internet of Things. We've got a great lineup of speakers today, and they're planning to share some really thought-provoking content. But before I turn it over to our presenters, I have a couple of things I'd like to review with the audience, a couple of ways that you can interact with us during the broadcast. First, if there's anything you'd like to ask our presenters, and we've left plenty of time at the end for questions, just click that questions button you see in the upper left-hand corner of your screen, and you'll be able to type your question there. You can also use that button if you encounter any technical issues during the call. And then we want to make sure that our webinars deliver value and meet audience expectations. So please take a moment after the presentation to tell us how we did, and you can do that using the Rate This button, which is just to the right of the questions button. All right, now I'd like to briefly introduce our 3 speakers. First of all, we have Chad Jones, who is VP of IoT Strategy, overseeing Xively at LogMeIn. Chad?
Hello, everyone. Hello. Thank you for joining us.
All right, and then we have Ian Ferguson, who is VP of Marketing at ARM. Ian?
Hello.
Ian's the one with the accent. And then we have our own Morten Bagay, who is CTO at Heroku.
Hey, everyone. Good morning.
And there are their pictures. All right. So before I turn it over, I have one more housekeeping item. We want to know who's on the call today. So we have 2 polling questions we'd like to ask. And you'll see these appear on your screen as soon as I start the vote. But the first question is, where is your business with respect to the Internet of Things today? So you have 4 choices there. First is not sure about how it applies to my business. Second is you know how it applies, but you're not sure where to start. Third is you're actively planning or executing a project. And then your last choice is currently have a connected product service already in the market. So we'll give that just a couple of moments more for people to vote. All right, the answers are pouring in. And then let's go to our second question. All right, so second question is, which departments in your company will be impacted the most by IoT? So let's start that poll. First choice is sales and marketing. Second is service and operations. Third is product development. Fourth option is finance. And then your final option is that you're not sure. I had to leave out all of the above. I ran out of spaces on my poll. So sales and marketing, service and operations, product development, finance, we're not really sure. Okay, it looks like Chad, I'll review these results quickly. Looks like we're pretty split on where your business is with respect to the Internet of Things. Actually, those are pretty even responses, so we've got a good mix here in the audience. And then let's stop the voting on our second question, and we'll look at the results. It seems that service and operations and product development are probably the most impacted by IoT. Finance is, I would say, a very distant fourth, sales and marketing in third place. So thank you all for responding to those questions. That helps us hear the content. So I think with that, Chad, I'm going to turn it over to you to take it from here.
Great. Thank you very much. And thank you, everyone, for taking time out of your schedules to join us today. The Internet of Things promises to not just revolutionize the way we understand our customers, but it promises to evolve everything we know about our world. Those are pretty lofty statements when we consider technology and the next set of paradigm shifts that will enable this. At the same time, as grand as it sounds, it's easy to get lost inside of that when trying to find the actual value and apply it to things that are meaningful to you, especially around how to apply it to your business. So today what we're going to share with you is a little bit, again, of what we view the Internet of Things to be, how your business can leverage the Internet of Things, and we're going to talk about the things that are necessary to evolve your business from a business perspective, not just technologies, but how they apply to your business cases. And then how to build those end-to-end connected solutions, what it takes to go inside of them and really build them to have meaning and value. And then we'll do this through the lens of a real company that has done this. They're named New England Biolabs. Some of you may have heard of them. It's a well-documented case, but it's an amazing transformation example of a company that leveraged the Internet of Things to extend their business value. So if we look at the evolution of the Internet, it really started with the first wave, if you will, where we started connecting PCs together. And that was the World Wide Web wave, if you will. So really information was connected on a one-to-one basis between one PC and another PC, which was a server. And we were selling about 1.8 billion PCs a year. So obviously an amazing market, transformed how we all live, breathe, and do business. But after a while, devices became more miniaturized. We ended up having an average of about 2.8 devices per person today, and I think I have a lot more than that actually. But the need became very apparent as mobile came to the forefront, that information needed to be shared between many devices. And it was more about connecting people together through the power of things like the cloud than it was just connecting two devices together. That's really moving to the tune of about 5.8 billion mobile devices are being sold every year. So about a fourfold increase in what we're looking at from the World Wide Web wave. However, the next paradigm shift in the Internet, known as the Internet of Things, the Internet of Everything, there's a lot of terms that are being thrown around it, promises to dwarf all of those things combined. Conservative estimates have it around 50 billion objects by 2020, and that's really about connecting everything around us. Finally taking the physical world that is a second-class citizen in the addressable market or the addressable network and making it a first-class citizen that I can actually address it, read information from things in the physical world, and then be able to control action in the physical world all through the Internet and through software that determines what is the best course of action. So really the Internet of Things is about connecting physical objects to the Internet, allowing them to become remotely addressable, readable, and controllable. When combined with other devices, cloud services, and applications, businesses gain exponentially greater understanding and evolved interaction with their customers, expanding revenue, optimizing operations while delighting users. Our physical world has so much to tell us about our business, but now it's dark. We can't get to it. But being able to take advantage of these cost-effective sensors that are so micronized to the point where they're no bigger than the dimple on a golf ball, and Ian will talk about that from the ARM perspective here in a little bit, we're able to literally learn everything or learn about things that we could never have a perspective on and do that very easily, and then tie that from an objective perspective into our business systems. Now, as I said before, people are estimating around 50 billion devices by 2020, but you've got Cisco out there talking about a $19 trillion impact of revenue. I mean, that's larger than the U.S. Economy, so at about 16.2 trillion. So I hope it's just a small percentage of that is accurate, but I think we're still going to have the largest technology market ever. But really, connecting things on the Internet is simply not enough. Being able to just understand the temperature of a room doesn't really tell me much unless it's in context of a particular business need. Now, we already have a lot of systems that we leverage for our everyday business. The power of Salesforce being the source of truth for a business is incredibly powerful and involves businesses to better deal with their customers. Having ERP systems that optimize supply chain and deal with logistics, business intelligence systems, all these things coming together, really evolve our businesses. But really, if we're able to take it to the next level, considering the advent of the physical objects and bringing their information in, it has to be part and parcel to the rest of those business systems. So in order to really build a complete IoT solution that promises to deliver on all of the fantastic vision that is out there, you have to go through a certain number of steps. We view it as 7 steps that tie together all of the necessary things in business to make this solution as valuable as possible. So the first one, we'll go through each of the 7 steps here, and then we'll take a step through each of them individually. So the first step is to identify the business case. That's the first step in almost any solution, or it should be, because if technology is created for technology's sake and does not serve the first order business principle, then it's doomed to mediocrity or failure. So the first thing is to really go through and comprehensively understand what the business case would be if you could have access to pieces of dark data that are out there that you can't really have access to today, except for maybe in a reactive mode with one human calling another. You know, it's almost to the point where you want to forget technology in this step and just think about the business case, because technology, given the vendors that are on the call today, can fulfill any of the actual business requirements that you need. You just have to think about them comprehensively first. And then creating a connected object is going out and actually building the set of sensors and actuators and tying them through gateways over the network to make them addressable remotely. Then you must build the infrastructure. And again, we'll go over each of these in depth here in a little bit. We need to build the infrastructure, and every single one of those lines, that you see underneath that category number 3 must be built. Now, a lot of times people will shortcut building things inside of the infrastructure, thinking that obfuscation is going to be a good security model. Well, you end up with cases like the one that's being prosecuted by the FCC right now, where a hacker found a set of open and unsecured baby monitors, hacked into one, and a man ran into his baby's room at 3 in the morning hearing a hacker shouting, dog trick commands to his 2-year-old. On one hand, that's kind of funny, but on the other hand, that's terrifying, because imagine a much broader world where we're going, where everything is addressable. So again, you can't shortcut a lot of these things in the infrastructure, because security is incredibly important, and people will rely on these systems. You then have to build applications, and not just the end user application that the users themselves will be interacting with, but the operations apps as well that do the management of the devices themselves. And then you have to tie into business systems so that objective information can come directly into different systems, CRM, ERP, business intelligence, and you go down the line, analytics systems, billing systems. Being able to give Salesforce the right information and context from a physical object is incredibly evolutionary. So tying those things together so that workflow can be automated based upon that information is a critical step. And then being able to build together the analytics of that information and doing the automation of workflow to make sure that a human doesn't have to be involved in every mundane decision that comes in. Things can be automated to a point where supply chain and logistics can be done computationally based upon the information, sure, reviewed by a human, but it involves not only the human's role in the entire business, but it also evolves the set of systems and the result that they have, where they can get to a point where they can even become predictive. And then in the end, being able to service and support not only the devices that are out there, but also the users in a just-in-time manner, so that you can ensure that the user has the technology working to its full extent, so that it extends their job or moves their job forward rapidly, which is the point of technology, is critical. So all of these things taken together must be considered and built in order to build this type of comprehensive solution based on the Internet of Things. Now let's look at each of these in turn and get a little deeper into each of them. So the first step, if you remember, is identifying the business case. Excuse me. So in order to best understand how to do that, the first thing to do is to look really at a real use case that is out in the world today. And so we're going to use New England Biolabs, as I alluded to earlier. Now, New England Biolabs is a company based out of Ipswich, Massachusetts, hence the New England Biolabs. They supply DNA experimentation acceleration components such as enzymes, proteinase lines, and reagents for research laboratories across the country, places like Genzyme, Biogen, for examples. Essentially what they're providing, just as an example, is they have the ability to cut DNA strands. I imagine those are very tiny little scissors that they use to do that. But then they offer glue to tie the DNA strands back together in different sequences. Other reagents allow you to clone that DNA, and again, use that for different experiments. Now, if New England Biolabs didn't exist, the researchers would have to create those enzymes themselves. It's very time-consuming and slows down the overall research. So there's a tremendous amount of value there. However, there are a couple issues. The customer really needed to accelerate their experiments with pre-made reagents. Right? At the end of the day, the researchers aren't interested in just buying reagents for the heck of it. It's all about accelerating things that can solve, some of the biggest problems that we have in disease states. Ordering for them is a very manual process. It required the researchers time to look through a big catalog. They weren't always sure what they were looking for, what the options were. Since that confusion was happening with the catalog, it demotivated the purchase as well. And the researchers had to store and inventory the products themselves, and some of these products are quite expensive. So you end up with a tiny little vial of a reagent that can cost you $1,500. If I have a small freezer full of those things, it's not like, when my freezer at home goes bad and I lose $200 worth of food, a freezer goes bad in Genzyme, all of a sudden, they lose $25,000, $50,000 worth of product. Now, for New England Biolabs, they wanted to create an on-premise vending machine, if you will, that supplied the reagents and understand those supply levels. And they couldn't do that as it was. So a lot of times, the unfulfilled orders that the researchers can't get to, drives them to their competition. So they needed to make sure that those orders were not just available, in overnight FedEx, but they were available literally right there. Just walk to the freezer at the end of the lab and pick it up. The delivery times also slowed the customer satisfaction because they were slowing down the research. And the expanded ordering of different things really relied on a general sales and marketing approach, which means that they were doing it kind of in the blind. So they didn't know which researcher was buying what product. And if they saw that Genzyme was buying a bunch of their glue, well, you don't need the glue unless you're using scissors to cut the DNA in the first place. And if they're not ordering a lot of scissors, well, why is that? Who's ordering the glue and not ordering the scissors? So there's a lot of dark data that's out there that would help their business if they could just gain access to that. So originally they started to think through the use case and said, okay, well, we've heard of this Internet of Things thing. And, if I take a physical object like a freezer and put it on site and I'll put on a weighting system so that I can see, what my supply level is, and the cloud, and kind of put the air quotes up, the magic cloud, we'll bring it all together with an app, I'll be able to check inventory state through a connected freezer. I'll record some activity. I can monitor my supply. Then I can just call the customers and say, hey, let's reorder, and then order stock for delivery. Well, that's fine. But you know what? That was only the tip of the iceberg of what could actually be the full potential of this scenario. So we were able to come in with them and say, okay, that's great, but let's think this through a little bit more. For just a little incremental investment, what if you could lock and unlock the doors through a magnetic lock? What if you could monitor if the door was open and closed? What if you could monitor all of the components of the freezer, because you can tell if the freezer is going to go bad and what the mean time to failure for that is. That's important, because if that freezer dies, that's hundreds of thousands of dollars worth of stock that is lost. And then let's track the inventory as you had originally discovered. Imagine recording all of that activity and creating a user interface that did it on a one-to-one basis, so that I could tell individually which researcher was using which product, which ones that they looked at, how long they opened a freezer, what they touched, what they didn't buy is as important as what they did buy, and be able to automate the whole purchase process. And then tie that in with Salesforce, with Sales Cloud, Marketing Cloud, and Service Cloud so that I could automate and understand all of the sales in real time. And then tie that with something like Epicor, because that's what's doing the supply chain delivery to those machines, and automate that process. And then actually automate or manage the entire life cycle of those freezers so that we understand exactly what's going on. Being able to tie all of those things together is the real requirement to make something work. In New England Biolab's case, that approach was something that would be truly evolutionary for their business. Because at the end of the day, what you want to be able to change is not just one aspect of your business. You want to be able to transform all aspects of your business and do so in a controlled manner. So really the areas in which you can do that are applied to 6 general areas. So the first is sales, where you can expand cross-sell, upsell opportunities by understanding exactly what is being used and when in the New England Biolab's case. You look at service and being able to do predictive maintenance and remote service and support and optimize the service chain. Operations and supply chain optimization, the break-fix cycle. Now, what about finance, where they can actually look at chain of custody and recognize revenue in a real-time way and manage risk better. And in product development, being able to say, okay, I know exactly what somebody is using and, importantly, what they're not using. If I have a printer that's got 6 buttons on the top of the printer, if the 6 buttons not being pushed, that's probably something good to know so that I can channel my innovation dollars in another direction, lose the button in the upcoming versions, or make it do something worthwhile to the actual customer. And, of course, marketing. Nobody likes to be marketed to, right? The rise of social media as a marketing tool was for this very reason, because it's more like a friend telling you, hey, you should check this out, as opposed to somebody sitting there with a sandwich board on the corner trying to get you to buy something. But imagine having information on someone's behavior that's so granular that when you market to somebody, they actually don't feel like they're being marketed to. They feel like they're getting information just in time when they need it. That's advice, and that is empowering, right? So marketing changes completely in this type of realm. So going through all of these business cases and this approach with New England changed their perspective on what they needed to do. So the next step for them was to create their connected object. And I'll go ahead and hand that to Ian.
All right. So as Janine so eloquently put, I'm the one with the accent. Yeah, so I think when you're looking at building the connected object, you've got to really think about 3 things. There's a sensing piece. What part of that physical world are you actually trying to measure? There's a processing piece. How much analysis are you going to be doing of that sensing there versus up in the cloud? And the third piece is the connectivity. And I think the important thing, Chad talked earlier about security, and we can certainly keep coming back to that. We clearly have to focus on that. Down at this level, the so what out of security is selecting your technology in that it doesn't come for free. There's more processing horsepower that you need to implement security algorithms. So the sort of sense of how much sensing, processing, and what connectivity you're going to do is kind of going to guide you to what type of board you're going to pick. And clearly, depending on the deployment model, do you have line-powered solution? Are you using a battery? That's also going to sort of dictate where you're going to go for which pieces of technology in the puzzle. And then you've got to connect it up. We see some people that are connecting that single sensor all the way back into the network, maybe through a cellular connection, for example. We also see people that will have a gateway. If you think about smart lighting systems, for example, people will probably have multiple lights around a city that get connected up to a gateway, and then that will connect back up into the network. So you need to think about that sort of topology of what you're going to connect up to. And then, as it shows here, then you've got to think about the networking strategy, and that is really going to depend on how close are the objects that you're measuring? Are you sort of measuring a whole load of things in a field and sending that very small amount of information over a long distance wireless connection to a gateway, or are you sending a lot of data to a nearby phone or a smart device? And that will guide, as I say, how you decide to sort of pick your connectivity pieces. So where ARM fits in, Chad mentioned very graciously earlier, we have some technology that has got pretty small right now. If you think about ARM, we are basically the equivalent of Gore-Tex in the jacket business, i.e. Gore-Tex don't make jackets, but the sort of fabric that they provide, the breathable fabric, is actually a desirable quality in jackets. And if you think about that moving into the technology space, that's kind of what we do. We don't make the chips. We actually make very energy efficient technology that fits into chips that other people buy, whether that's Broadcom, whether that's Linear-Tech, ST, Samsung, etc., etc. So we're basically the Gore-Tex of high tech. And really, like I said earlier, you have a very scalable set of things going on in IoT. One size does not fit all. You're going to have some applications where you do an incredible amount of processing locally. You're going to be running big operating systems, and you're going to have other places where the device wakes up, takes a small measurement, and communicates that maybe every week, and you want the battery to last for a month. So a very different set of use cases, performance, connectivity requirements, and that's really what we do, is we provide a very broad range of processing technologies from which people can select. With that, I'll pass on the ball.
Great, thank you, Ian. So, ARM is driving, if you look around your table where you're at and look at the devices around there, I'm sure you're going to probably see, at least, in your phone, 8 ARM chips alone. ARM is really powering a lot of the innovation coming on the Internet of Things, and the platform that's in the dimple of the golf ball is quite impressive. Moving on, now that you have a connected object built, you've got to be able to have command control and send data somewhere, and that involves the infrastructure. So building the infrastructure is really all of the things that you see inside of the blue section in the white text. Building account management, real-time data support, remote access, messaging, the web interfaces, API, routing, the security around all of these things, file storage, the support timing, rules engines, all of those things have to be built. Now, a lot of times people look at something like doing it yourself on top of Amazon, or on top of infrastructure as a service in some way, and that's certainly an approach, using open source software, things like that. But you end up having to build all of those things that are lined out here and be able to load balance them and then geo-balance them to make sure that the system is as robust as possible, and of course manage that over time. This is the unifying factor that brings these things together. So again, if you're looking at doing it in this way, you have to consider these things and make sure that as you build them out, each of these are built in a way that can scale and can also be secure, so that you don't have that case of a baby monitor being hacked just because people were cutting corners. Now, you'll see in the future here how we all help with this, but it is important to understand that this is the reality of building these solutions first. Now, once the infrastructure is built, creating applications that leverage these things is the next step. And there's some amazing use cases that are out there today. But fundamentally, they fall into essentially 2 categories. There's the line of business application that actually uses or interfaces with the customer to forward the goals of the business interacting with that end user. And then there's an operations app, which is the back office application that looks at the monitoring and control, break-fix cycles, and those types of things of the system as a whole. You have to have both. Because if you're going to end up doing things like firmware updating, because you will have bugs, everything has a bug, you have to be able to update that efficiently. You've got to be able to monitor break fix and be able to see status and do provisioning, deprovisioning, all those things. So operations apps are important. Certainly line of business apps fall on iOS and for mobile and Android, those types of things. But still, you can't rule out line of business applications working on direct interfaces, like in the New England Biolabs case, where a tablet sits in the door of the freezer and that interacts with the customer. Beyond that, you end up having some PC-based applications as well, right? You've got to use a normal browser. So all of these things come together for the application. And of course, there's really no better app platform to rapidly create apps tied in with your business solution than with Salesforce. So I'll turn that over to Morten.
Hey, everyone. So I think the operative word here, or the operative experience, I should say, that we've learned from our customers in this field is that the Internet of Things really powers a new ecosystem of applications. That is, once you've actually got the data stream flowing from devices, it's not just about integrations to business systems. It's also about what new applications are you going to create to take advantage of this data and what you can do with it, whether that's powering new revenue streams, creating new experiences, or new insights for the business. And the way we look at this is roughly as a two-sided ecosystem, as Chad mentioned. On the one hand, there's an extreme amount of focus on creating new and engaging customer experiences. For example, providing customers with new control capabilities for controlling devices and visualizing information from them. So some of you may have already experienced this in your personal lives through amazing apps such as the Philips Hue lighting control system, or maybe the automatic connected driving assistant. They're both good examples of that. So those are examples of the customer-facing, engagement-oriented apps. On the other side, it's all about what the business needs to take advantage of this data. It's the dashboards and near real-time reporting that provide insights into how customers are interacting with your products and your brand. It's also the human workflows like customer service that are now transformed and powered by automated up-to-the-minute case creation. And it's the marketing tools that let us react quickly and create personalized outreach to individuals based on the specific behaviors that we see in the data, as opposed to sort of previous eras, mass market, shotgun approach to marketing. Now, what we see is that creating applications for customer needs and internal business needs are often two very different concerns that speaks to different developer constituencies. So we see one, for example, customer-facing apps placing a lot of emphasis on the latest and greatest UI, high scale to be able to deal with high traffic loads, and speed, both in terms of performance of the application and time to market. While the other internal business-facing app more emphasizes things like workflow, data integrity, audit trails, etc. The Salesforce platform is really unique in that it offers two incredible high productivity solutions, each tailor-made for these individual purposes. So on the one side, we've got Force.com, which is our platform for building internal business-facing apps, your standard workflow apps, dashboards, reporting, etc. And then on the other, we've got Heroku. So Heroku is a platform for professional developers, allowing them to build applications in any language, any framework, and run those applications at high scale. We very often see this deployed in this IoT area for building mobile applications. So, for example, the applications that customers can use to control devices and view information from them. The secret sauce between our platforms at Salesforce is our data synchronization engine called Heroku Connect. So very often what we see in the field is that customer-facing applications get built, but they have very, very poor connectivity and integration with the business systems behind them. On the Salesforce platform, this is not the case. A key part of our technology is this core integration solution called Heroku Connect, which makes data sharing between customer-facing apps and the business apps behind them seamless and automatic. As you will see, Connect is a key part of our application architecture for all of our IoT customer solutions. The main thing that it does is dramatically allow us to cut down the development time by not having to write integration code. So that's a very, very brief look at how the Salesforce platform powers an entire ecosystem of apps around the Internet of Things. There's a lot more detail here, and I'll certainly be happy to take questions later on, but for now I'll send this back to Chad.
Great, thank you, Morten. And the power of what Morten's talking about with Salesforce is just incredible. I mean, the Internet of Customers that Salesforce continues to push forward, powered by Heroku and Sales Cloud, Service Cloud, Marketing Cloud, combined with objective data, is just nothing short of evolutionary for what businesses understand. And certainly, we'll show the tie-in with that through New England Biolabs. The story continues on that front as well, where the applications that we have tied into business systems is really the huge step to evolving how businesses understand their customers. We talk about Salesforce with Sales Cloud, Service Cloud, Marketing Cloud, and that's the CRM aspects. But certainly ERP systems, the SAPs, Epicors, you have things like ServiceMax, Financial Force, logistical applications, on and on. Being able to tie those physical objects and their data and then creating new applications, as Morten had talked about, bringing all those things together, that is the way to fulfill the evolutionary promise of the IoT. So Morten, talk a little bit more about Salesforce.
Yeah, absolutely. So I think this also goes a long way towards answering the question of why is Salesforce so concerned with the Internet of Things. Again, the reason we connect devices to the Internet is not because the data in itself obviously is interesting, but really the promise here is how having that live connection to what your customers and what your products are doing, how that potentially transforms the core business functions of sales, service, and marketing, which of course are the core businesses of Salesforce. This is where for a decade now we've been delivering the leading enterprise systems. So when we talk to customers about IoT, it's first and foremost about how they want to transform the core functions of sales, service, and marketing. And with Salesforce, we provide you cloud solutions that are already enabled to do that.
Great. So again, Salesforce, is the business driver and source of truth. So tying together the object information and making sense of it in context is what really is evolutionary. Because once you get to that point, applying analytics and automation to it really becomes incredibly powerful. So this is really kind of an evolution, if you will, in these 5 steps in analytics and automation. Initially, when data comes in, you can do reporting on it. So you can start to visualize trends in the data with dashboards, things like that. But a human can look at that and to begin to make decisions based upon that reporting. Over time, you can do pre-processing on the data to discover what the outliers really are, clean out the raw data for parsing, set some basic triggers, and really filter out what is important, and then begin to add context on top of that as well. You can eventually start exploring the different data sets, so you can draw correlations between non-intuitive data sets to all of a sudden create entirely new learnings that can help drive business. And then eventually you get to the point where all sorts of deep learning can be applied. Bayesian and other predictive algorithms can be applied so that I can predict when something needs to happen, not just in fixing like the freezers in the New England Biolabs case and predicting mean time to failures and those things, but being predictive and just-in-time restocking of products that somebody might need in the future based upon historical use of current products. You go out and predict how you actually can do things around product management and roadmaps as well, and get very predictive about what a business knows to the point where you're becoming almost psychic. And then acting on that in an automated fashion so that the system becomes so intuitive that it knows what the right reaction is and feeding back information to the physical world to respond to the conditions as they occur. Now, of course, at that point, humans are still in the loop, but they are evolved to a point where they're setting the strategic parameters of action, if you will, and the system just reacts to that, as opposed to being 100% reactive, and a human then has to perform action after an event has already occurred. So really, the promise is that over time, these analytics will take your system to a point where, I'm not going to quite say it's Skynet and rise of the machines, but it could be to the point where it's rising machines in a good way, where it's taking care of those mundane details and evolving the roles of humans in their world. So then finally, doing maintenance, service, and support is the final step, and considering things like remote firmware updates, because you're going to need to update the functionality, close bugs, those types of things inside of your objects themselves. So you have to consider, how do you do remote firmware updates? Remote support, because a lot of these devices are headless. That means that there's no screen, no keyboard, no mouse for you to actually interact with, so you've got to be able to remotely get at them and reset them or gain information from them from a support standpoint. And then pure remote access, being able to see what a user sees when they are interacting with some sort of object. That's an important aspect as well. That's not the ending of support, but it's definitely a good starting point to ensure that you have a system end-to-end that is supportable as it moves out into the wild. If something is wildly successful, then you could have hundreds of thousands, if not millions, of these objects out there. You can't go back later on and then build in support. It has to be something that's considered from the get-go. You can also consider things like chat functionality inside of applications. If somebody isn't quite sure how to use something, being able to have a chat window at a moment of need helps people become empowered. So again, support is a large thing that should be considered from the get-go, along with the other steps. So that's a lot of information about how we actually have to consider all of the different things to make a comprehensive solution. But bringing it all together, and the point of why we are here, is really how the 4 companies that are on this call can help you accelerate bringing your idea from its first conversations all the way to production. So ARM is about the connected objects, enabling those connected objects through an incredible set of computing platforms that power some of the most widely used platforms that are out there today. Things like the Texas Instruments, TI chipsets, Apple iPhones use them, Android, you go down the list, ARM is everywhere. But they have the Mbed platform, for example, that can do rapid prototyping of different connected objects. But end-to-end ARM is the accelerator for creating these connected objects. And then Xively is about object and business integration. We're the platform as a service that ties together the business intelligence systems, the applications, and the connected objects, and routes information as needed to the systems that will then perform automated workflow and actually create the end-to-end solution. Salesforce is the business intelligence center, the source of truth for the business that has all of the relationships with the customers and is evolved by tying together the physical objects into the workflows and the application enablement platforms that they have through the Salesforce One platforms, the analytics that they offer. And then Heroku, as you heard Morton describe, being able to have a platform that can rapidly create customized applications for the professional developer and host that in a scalable and secure way is incredibly powerful. But taken together, these things accelerate the overall process of bringing your idea from realization to production. Before the combination of these things, the 7 steps takes literally a year of man time, if not $1 million, depending on a lot of situations. But afterwards, considering all of these technologies, you actually see a fraction of the time necessary and a fraction of the investment that's required as well. Plus, you're able to evolve the entire functional set because these things are taken care of for you. So let's see what that really means inside of our use case. So in New England Biolabs, we ended up creating an HTML5 application hosted on Heroku. It's tied into Salesforce. And then a freezer, a vending machine, if you will, through a freezer, was built with a locking mechanism, temperature sensors, door sensors, and it's monitored via Salesforce and the application on Heroku. We do mobile device communications through the Xively cloud, and we take care of all of the security inside of that, all of the connectivity libraries to make those objects come onto the cloud very simply, and then be able to standardize that API through a RESTful interface and tie that into Salesforce and into Epicor, which is the ERP system. All of those things come together to create the solution that's extended out through a tablet on the freezer door in the current iteration, but soon we'll move to an actual mobile device. The architecture looks something like this. We have all the sales, service, and marketing cloud tied together. The Heroku app is being hosted and delivered to both the tablet on the device itself, which that's how the device looks today, and then tied to the actual, the future version of a phone-based app. So you'll have a headless freezer using near field, those things, because I know exactly who you are through that application, and we get the same results. And then Epicor does the supply chain. Now, the results are pretty stunning. So now, if a researcher walks up to the freezer, taps his badge, we now have a one-to-one understanding of what that freezer's actions, or what that user's actions are. Let's say they open the freezer door, stand there for 2 minutes, and close the door, log out. Well, that's meaningful, because that user probably doesn't understand how to use the freezer or what is inside of it. So Marketing Cloud will generate a message, send it to the user, and say, hey, we saw you were in the freezer, here's how you use it, here's what's inside of it. An hour later, user goes back, taps his badge again, opens up the freezer, picks up Prodinase line A, Prodinase line B, puts it back, closes the freezer without buying anything. We generate another Marketing Cloud message that says, hey, we noticed you touched Prodinase line A and Prodinase line B. This is what they're used for, what experiments they're typically used for, and again, how you use the freezer. Hour later, they go back, tap their badge, again, open the freezer, grab Prodinase line B, scan it, purchase it, log out. Now, what we've done in a very short amount of time without human intervention is understood what that user needed, what were the roadblocks to him becoming successful to move his research along, in interacting with the freezer and the contents of the freezer, and then being able to have a mini nurture campaign. And in marketing terms, that's moving him along the sales process. Now, he didn't feel like he was being moved along by a marketing campaign. He feels like he was getting advice just in time when he needed it, so that he could go back to understand how he could get what was needed to accelerate his research. That is empowering. That is advice. It is not seen as marketing, and that is very welcome and delightful to the end customer, to the end user. Sales Cloud tracks all of the sales, and once every 5 days it will drop to Epicor a list to restock the freezer automatically, but a human will be able to look at that and say, based on what's being used, a scientist might say, well, let's pre-stock another line of things and then generate a marketing message saying we have these other reagents because we see where that marketing house is going to. Let's get ahead of that use and maybe expand our capability. And then Epicor supplies that through its automation. And then we can monitor the freezer, and if the freezer ends up sending freezer not okays because the chiller's starting to go bad, we can predict the mean time to failure, and let's say that through Service Cloud. And let's say that mean time to failure is 6 days, but we can't get anyone there until the 7th day. Well, the Service Cloud can tell the freezer, up your temperature by 4 degrees because we know the stock can handle it. And then that opens up another 2 days because we've taken load off the chiller, and that now is applicable to the open window to get the technician there. And when the technician shows up, it's not a truck with 5 equivalent freezer parts of freezers. It's actually him arriving in a Prius with one part, the chiller, and he just switches it out, reports back everything's okay, and the stock is fine. So the use cases to just go on and on to product roadmap and all of those things, but at the end of the day, we're seeing a transformation that is highly valuable at a much lower cost point that affects wide areas of New England Biolab's business while actually producing a much greater customer and user experience. So everybody is happy in a win-win situation. New England Biolabs is making more money on top of that, but at the same time, the research is being accelerated. The best part about this, and the whole reason why we are here, is that the initial handshake with New England Biolabs to the first 5 freezers in production, leveraging the 4 companies that stand before you today, was less than 100 days. That is unheard of when you're building these situations from all the research we've done, but we see this continually through the customers that we engage with between our 4 companies, and we believe that we can help you reach those same goals by thinking through the business case, shortcutting all of the steps that you see inside of that between infrastructure, the objects, connecting in with the relevant systems, getting your application up and working, and then seeing truly transformative results across all aspects of your business. So with that, if you'd like to contact us, here's some information. We also have a white paper on top of this as well. And then, what we'd like to do is go ahead and start opening up for questions as we go ahead and just say in conclusion that, building connected products really can be tough. And in order to have a holistic transformation, you have to follow all 7 steps. You just have to. Otherwise, if you don't follow them in the beginning, you will eventually find that you must grow into them, must think about them from the starting point. Our 4 companies together in our particular areas are able to accelerate that for you, and we look forward to helping you do so. So with that, I'd like to turn over the floor to questions.
Yeah, so Chad, I was just looking at the questions that came in while you were talking, so I can let you have a look at a couple of the others as well. So one which maybe I'll just have maybe Morten or yourself can answer is about whether the technology integrates with existing analytics tools like Tableau, Qlik, I can't even say it, QLIK, and Business Objects. While you think about the answer there, the other one that I thought I'd pick up was a really good question about where the intelligence will reside in the IoT system. Is it going to be in the edge or is it going to be in the cloud? And like all marketing guys, I guess I'm going to say it depends. Like I mentioned earlier, I think if you see power-constrained systems or cost-constrained sensors, most of the processing is going to be in the cloud because the extra performance requirements you need, it's going to be really hard to hit the cost point you need out on the edge. So I think certainly power-constrained systems or very, very cheap systems, as much performance as you can get in the cloud is going to be the answer. And the edge is going to simply communicate, obviously secure the data, but then push it back into the cloud. You think of a sort of the Shazam kind of app equivalent in the phone, where all it does is it moves it up into the cloud. I think the exception is if the network connection isn't always there, or is unreliable or slow, you will start to have more processing out near the edge, or if that data is going to want to be staying out nearer the edge as opposed to pushing it up into the cloud. So again, as another quick example, for those of you that know the Waze app on maps, historically all of that information was up in the cloud, and if you were driving around and you lost connectivity, then the app couldn't work out where you were. Newer versions of Waze has actually cached a lot more of those maps down on the phone. So if you think about in that IoT area, you could imagine more intelligence for pushing out into the client for those sorts of apps. But I think generally, we're going to use the power of the cloud more and more, and that will enable very cheap devices out on the edge that have long battery lives. And maybe with that, I'll hand over to that question about the integration with existing business analytics tools.
Yeah, this is Morten here. Maybe if I could just add one more point to the question you were just answering. One other key aspect is that in general, from an app development perspective, the agility resides in the cloud, right? So if you have a deployment of many hundreds of thousands of devices, for example, obviously changing the firmware of those devices is possible, but not as easy as it is changing the logic in the cloud. So generally, from an agility perspective, we try to keep as much of the central processing logic there as possible, just because it's easier for us to modify it there.
Great. Thank you, gentlemen. So then taking the, do you integrate with existing BI analytics tools like Tableau, Qlik, Business Objects, et cetera? The answer is yes, but the way that we do it is through a RESTful interface, which is an open standards-based interface. And all of those tools understand how to interface with REST. So being able to tie in third-party systems in that manner is is definitely an option, and we've actually shown different internal connections with that. There's other systems I previously mentioned that we've integrated with, such as ServiceMax, Financial Force, SAP. We can continue to go down the list for that, but certainly we can help you with that. And then there's one other question around, is there a central systems integrator that can help you with this? And certainly Xively is the one that can help you with that. We offer 3 services. It's really the services aspect for system integration and to help you with the business, walking through the business cases. Certainly, as you see in New England Biolabs, we played that significant role inside of that in bringing those systems together. We do have our platform as a service that acts throughout all the data around bringing those things together, and then we have a partner ecosystem that we leverage the innovation of those customers or those partners to bring together the solutions as quickly as possible. Again, as you see in the New England Biolab example, that was less than 100 days. So we can help you with that, but the 4 companies work very closely, hand in glove, if you will, to make sure that we bring a real system of value to you that's well thought through, it's comprehensive, and will have the transformation that is promised for your business. So I believe we're at the end. Let's see, do we have any other questions? Let's see. The slides will be available at the same link. BrightTalk will send that back to you, so there will be a link for these as well. Again, if you go to the Xively website, there's the 7 steps for business success on the Internet of Things as a white paper that you can download. Please feel free to go there as well. And let's see if there's any other questions here. I think that is about it. So with that, I'll go ahead and say thank you very much, everyone. And Janine, would you like to close us out?
Sure. So everyone, thank you for attending today. I hope you found the content valuable. Please take a moment to rate the content before you leave. And to all of our speakers, thank you for a great presentation, for all the work ahead of time. As Chad mentioned, a link to the recording, or actually the recording will be available shortly after we conclude. So if you want to share the content or revisit any of it, you just come back to the same link. And with that, we'll end the call. Thanks again.
Thank you, everyone. Enjoy your day.